okay? And you can always check it. Go ahead in your calculator, do 15 times the square root of 3, and I'm going to get 25.98, da, 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 da. If I just do the square root of 675, I'm also going to get 25.98, da, 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 da. Okay, so either way, you should get the right one, but again, it's our puzzle to get this number inside the radical to be as small as possible and as many things outside. All right, example 2, like I was saying, we have variables and numbers, so we're going to first step, break apart the numbers from the variables. Numbers in one house, variables in the other, okay, separating our terms. Now, almost like cover up this s squared, we'll come to that in a second. Instead, we want to break apart the 24. So we're going to go to our list of perfect squares and we see what goes into 24. Well, 24 would fall right in here. 24 divided by 16, nope. 24 divided by 9, nope. 24 divided by 4, ooh, we have a winner. So this is going to break into the square root of 4 times 6. Square root of 4 is going to get its little house. Square root of 6 gets its little house. Square root of 4 is 2. Square root of 6, nothing else divides evenly into it. And if you're not sure, go back in your list. You could almost do it with that one too. Square root of 6 would fall right in here. Does 4 go into it? No. 1? Yeah, well, everything. 1 goes into everything. So you can always check it that way. So we've broken apart the square root of 24. Now, if we go to this part, what's the happening of when we have a square root of a squared number? They cancel one another out. Square root and squaring are inverses. So that s comes falling right down. Now, one last thing on this problem, lots going on here. This is the right answer. It's 2 square root of 6, and then the s is on the outside, but we don't want to write it this way. And I can show you better when we're in class. But this s, let's say you're a sloppy writer and you don't really make your square root sign, you don't make it end at the right spot. Is this s underneath the square root sign or not? It can be misleading. So instead, anything that is not under the square root sign, put it in the front, okay? So it's going to be 2s square root of 6. Put that in the front. That way we know everything that's not in the square root is up front. Anything from the square root sign on is underneath, okay? All right, let's try letter B. What color? We'll go with a tungsten. All right, first, break apart the numbers and the letters. Square root of 54, I'm going to see what goes into it. Does 49? No. Does 36? No. Does 25? No. Does 16? No. Does 9? Yes, it does. Now, I've done these many times, so you obviously, I was saying them a lot faster than you could type them in a calculator, but 54 would break into 9 times 6. Square root of 9, and then we have the square root of 6. Square root of 9, they each have their own little home. Square root of 9 is 3. Square root of 6 stays underneath the square root symbol. Square root of t squared, they cancel one another out. T falls down, but we're going to put it right there before the square root. 3t square root of 6. That's the answer. All right, letter C. Square root of 176, square root of a squared. All right, so let's go to work. Square root of 176. Let's see, 176 divided by, would fall right here, 169, nope, decimal. 144, decimal. Square root of, 179, not the square root. All we're just doing is dividing. Is 176 divided by 121 a decimal? Yes. 176 divided by 100 a decimal? Yes. 176 divided by 81 decimal? Yes. 176 divided by 64 decimal? Yep. 176 divided by 49 a decimal? Yep. 176 divided by 36 a decimal? Yes, it is. 176 divided by 25 decimal. 176 divided by 16? Oh, that one works. Sometimes you're going to have to go quite a ways through it, but again, it's worth getting it right. All right, so square root of, this is going to be the 16 times 11, because 16 times 11 is 176. I break them both up into their own little square root symbol. Square root of 16 is 4. Square root of 11 stays underneath the square root symbol. Then I have this a and the square root of a. They cancel one another out, so my a is going to go up front, because it comes out of the square root sign because it's gone now. It canceled with the squared. All right, last one. Square root of 300, square root of x. All right, square root of 300, way off the chart. So I divide by 225, no luck. 196, no luck. 169? Nope. 144. 121. Ooh, 100. Yes. And again, check each of them. Don't just go with what you know goes into it, because you want the largest perfect square and you don't want to miss anything. All right. Each have their own little house. Square root of 100 is 10. Square root of 3 stays underneath the square root symbol. Now we get to this here. Is this going to cancel? Nope, it's not. We don't have x squared, we just have x, square root of x. Nothing's going to cancel out. So that means that x is going to stay underneath the square root sign. It's staying there. There's no reason for it to come out. So my final answer is 10 square root of 3x. All right, let's go on to the next part. We have dividing, the quotient property of square roots, another cool tool. So here we have both of them underneath the square root symbol. I'm going to break them apart so that I'm going to observe the difference between them. Jumping the gun a little. Square root of 100 over 4. This is what we said one of our rules was we cannot have a fraction under the square root symbol. So the first thing we have to do is see if that can be simplified. Whatever is underneath the square root symbol you have to do first. 100 divided by 4 is 25. So really this is square root of 25. Square root of 25 is just 5. Then we look here. Square root of 100 over the square root of 4. Square root of 100. They each have their own little house. That's 10. Square root of 4 is 2. 10 divided by 2, 5 again. Okay? So it works for both of them. They each have their own answer. So the rule in this one, just like we had with multiplying, is that we can go ahead and give them each their own little house, and we're going to work. It will work out. So square root of a over b is the same thing as the square root of a over the square root of b. This works if we're dividing two things just like that. So let's try some. Example A, simplifying the square roots. We want to break them down as far as they can go. So first what I'm going to do is give each the square root numerator and denominator their own square root symbols. So I have square root of 13 over square root of 36. Now I'm going to work through and break down the square root of 13 as far as I can. Let me make my list real quick. I'm just going to make my list of perfect squares. It went 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, excuse me, 144, 169, 196, 225, and I hope I didn't miss any. So these are all the square roots, and we know what they equal. We've been doing them so much by now that it just goes in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 15. Okay, so square root of 13 would fall right in here. 9 doesn't, 4 doesn't, only thing going into it is 1. So this is not going to reduce at all. It's a prime number, so that might have tipped you off. Square root of 36, ooh, that's a perfect square. Square root of 36 is 6, so that just reduces to 6. We do not have a square root symbol in the denominator, so we're good. We don't have a fraction underneath the square root. It's our final answer. Square root of 13 over 6 is perfect. All right, let's try letter B. I'm going to give each of the numerator and denominator their own little homes. They each get their own little house. Square root of 15 over the square root of 16. Square root of 15. In my list, 9 does not divide into it evenly. 4 does not divide into it evenly. If I get to the 1, then I realize that that can't be reduced any further. It just stays underneath the square root symbol. Then I take a look. The square root of 16 is one that I know. Square root of 16 is 4. That's it. That one can't